Hello, everyone, and thank you for joining our SE Hangout Terraform for Non-Developers catalog-based workflow using ServiceNow and Terraform Cloud Business Tier. Hope everyone is staying safe and healthy out there. Today, we have HashiCorp Senior Solutions Engineer, Stenio Ferreira, presenting. We're going to discuss how the ServiceNow integration can be leveraged to enable users to deploy Terraform resources without needing to manipulate Terraform code. I'd like to note that the webinar is being recorded and the recording will be made available after post-processing. I'll email it out to everyone. Please submit your questions throughout the presentation through the Q&A portal, and then we will answer them at the end. So with that, let's go ahead and get started. Take it away, Stenio.
Thank you, Alison. Hi, everyone. Like Alison said, my name is Stenio Ferreira. I'm a Senior Solution Engineer at HashiCorp. Have been working with the company for the past 3 years, I think. And today I'm going to talk about the different workflows that are available with Terraform, both from the open source perspective and from Terraform Cloud perspective, and emphasize this workflow utilizing the ServiceNow integration that's great for non-developers. So this is the agenda of what we're going to cover. Just a brief overview of Terraform for those of you that might not be 100% familiar with the tool. Then I'm going to talk a little bit about the workflows possible with open source, and then the different ones available with the enterprise version with Terraform Cloud. And finally, I'm going to summarize everything with a few considerations. So I assume that everybody knows Terraform is one of HashiCorp tools that serves to describe your infrastructure as code. So whenever you're provisioning resources to cloud platforms like AWS, Azure, GCP, VMware, you can describe those resources using Terraform as code. So you're going to have a Terraform file like this main.tf. And in this file, there's going to be different blocks, different structures that are going to represent these objects that Terraform is going to create. So Terraform has a language that supports different types of objects. We have, for example, the providers. Those are the platforms where your infrastructure is going to exist. Those of providers are AWS, Azure, VMware, etc. You're going to have the resources block. So those are the resources that are going to be created, like virtual machines, security groups, etc. There's a data block where you can reference existing resources, like if you want to reference an existing network, subnet or VMID or something like that, you can use this data block. You can use variables. So this code is reusable. You can use for different environments like dev, prod, QA, etc. And there's a few other blocks, but another example is the backend, where you can specify where the state file is going to live. So the state file is how Terraform keeps track of these deployments. So talking about the available workflows for open source, there's going to be a manual workflow and an automated. So when we talk about a manual workflow, this is usually how people and companies start using Terraform. So you can store your Terraform code in a Git repository, so you have a version control. And you can define some shared resource to store the state file. So in that backend block, you can reference S3 bucket or shared file system or a database where this deployment of Terraform is going to keep its state file. And the users, usually developers that are dealing with Terraform, they can execute plan or apply. Plan is a dry run, and apply is an apply. So this is a manual workflow. And eventually, when teams evolve their utilization of Terraform, they can automate this workflow. So instead of doing these manual plans and applies in the different workstations, they can connect the Git repository to a CI/CD tool like Jenkins or CircleCI. And now the workflow changes a little bit. The developers can just interact with the code, like do changes in the resources, variables, etc., and send to the Git repository. And this CI/CD tool is going to pick up that there has been changes, can execute any tests or validations, and has the responsibility of doing the plan and apply. So this is already an improvement on the previous workflow because it's a little bit more consistent, and because it delegates the plan and apply to this centralized resource, it allows an approval process and allows better collaboration. Having said that, a lot of companies, when they move to a more production environment, they face a few challenges with this workflow. The first one is in regards to operational efficiency. So now we're talking about large companies. And these companies, now they have to manage this CI/CD tool, the S3 bucket, or whatever the state file is being stored, which for small teams might not be a big concern. But when we're talking about large organizations, maybe those resources are shared with other teams. Maybe you don't have the right level of governance and control over these resources. So there's complexity managing these externalities. The second challenge is regarding security. So it's very common for smaller teams, for the developers to have their own API keys for the platforms, or the permissions to change Terraform code is based on the Git repository, so there's no centralized approach. And finally, there's a lack of governance. Terraform is a very powerful tool, but especially when you're talking about production environment, it's very important to have controls and checks and not just allow any contributor to change your infrastructure. So those are the limitations of the open source workflow, and that's the reason why HashiCorp created this enterprise version, the Terraform Cloud. So with Terraform Cloud, instead of having to rely on a manual approach or external tools, you're going to have this centralized server that's going to address this operational efficiency requirement. So it's much easier to manage everything from a centralized point, that your infrastructure provisioning, everything is defined in this server. You're going to have greater security as well, because Terraform Cloud is going to allow you to create role-based access control. So you can have your different users with different permissions. Maybe a few of your developers have access of plan and apply to the dev environments, but for production, you want to have it more limited, for example. You also have the ability to manage sensitive variables from within Terraform Cloud. So instead of having to share these API keys and database credentials and other secrets to these external tools or to the developers, you can centralize everything in Terraform Cloud. And also, Terraform Cloud is going to manage the different state files of the different deployments. And these state files are going to be encrypted. So you won't have to worry if somebody goes behind the scenes outside of Terraform Cloud. The state file is going to be encrypted. So even if somebody has access to S3 bucket or to Azure Blob or whatever these state files are stored, they're not going to be visible. And finally, Terraform Cloud is going to offer governance. There's a tool called Sentinel that allows a company to define best practices and what are the standards of a company, and also to prevent unsecure deployments before they happen. So the way Sentinel works is it runs after a plan to validate that the resources that are planned to be created, changed, deleted, etc., are within the standards of security, governance, compliance regulations of the company. And also it's going to offer cost estimation. So these are just the features of Terraform Enterprise. It's not the main objective of this presentation, but just to give a sense of the evolution of workflows. From open source, there were the limitations and manual and automated. And now with Enterprise Terraform Cloud, there are these additional benefits, and we're going to see the different workflows that are available. The first one usually is the workflow that most companies start, is integrating Terraform Cloud with version control systems like Git. So this is going to be a similar workflow to the automated one for open source, where instead of the developers doing a manual plan and apply, you can rely on them just interacting with the Git repository. And whenever there are changes, this Git is going to notify the different workspaces that are registered for each deployment. So for example, let's say that you have a Terraform code to describe your networking stack of your dev environment. So maybe it's AWS, and in this Terraform code, you describe virtual VPC and two subnets, for example. And using the variables, you change the variables to make sure that it's for dev. You can create this workspace with this definition and tie it to the Git repo. So whenever there are changes to this Git repo, it's going to notify the workspace, and Terraform is responsible for executing the plan, cost estimation, sentinel checks, and eventual apply. Keep pressing next. So regarding considerations, like I said, this is usually the entry-level workflow because it's a very natural evolution from the open source. It allows the developers of Terraform code to continue having self-service, but it provides a measure of governance. Like I mentioned, each workspace can have role-based access control, so you can determine which developers can participate in which deployments. You can manage your variables at the workspace level, so it provides greater security. And it also is going to provide automation. So it provides pretty much the best of all worlds. It's very similar to the open source automated workflow. The second type of workflow is actually two types, but I bundle them together because they're very similar. Usually, this makes sense for companies that are already quite advanced in their Terraform open source use, and they're comfortable with a CI/CD workflow, or they're using some external Azure DevOps or something like that, and they want to keep using this external tool. So they want to add Terraform Cloud's greater governance and security, but they don't want to use the Githook. They want to still maintain their existing workflow for minimal disruption. And this is possible. So you can continue using your CI/CD tool. Instead of calling the plan and apply the traditional approach, now you can do API calls to Terraform. And these API calls can issue commands to the different workspaces. So in the end of the day, it can be quite similar to the VCS Githook that I just explained. It's just a different approach to give greater flexibility if that's a desire of the company. And in the case of remote state, you would just change your existing code. Maybe your backend is pointed to S3 bucket or something similar. You just point the backend to a Terraform workspace, and you can still rely on the CI/CD tool. It's pretty much minimal disruption to the existing workflow. And once again, it brings the benefits of the enterprise version of Terraform. Like I said, it allows minimum changes or disruption to existing workflows, but still providing governance. And finally, there's the ServiceNow workflow. And one of the reasons why I decided to make this talk is that at the end, I'm going to give 2 links to a blog post and some documentation. But I felt that so far, the documentation has been focusing more on the configuration, and I didn't see a lot of discussion about these different workflows. So the idea here is, okay, great, Terraform has been working fantastic so far, but it requires its users to have some sort of knowledge of Terraform code or of the resources that want to be deployed. And from time to time, we work with companies where they want to expose this service of creating infrastructure to a greater audience that maybe not necessarily needs to be dealing with Terraform code on a day-to-day, or doesn't know the distinction between a EC2 or a VM. They just need something to be present. And this ServiceNow integration is going to allow just that. So in a sense, it abstracts the complexity from these users, and where an admin can configure the catalog items, so what kind of infrastructure resources are available to be deployed. And these users can use the ServiceNow interface. It's in the browser. They can just create a ticket, and this is going to create the infrastructure. So it gives them the power to manage their own resources without having to deal with the complexity. And behind the scenes, we have all the governance and security provided by Terraform Cloud through this enterprise workflow. Examples of actions when these users interact with ServiceNow: they can just provision one of the available resources. So there's going to be the different catalog items. They can select one and it's going to be provisioned. They can update an existing one, so they'll have visibility of what has been provisioned using this integration, and they can do changes, update, etc. Or if they have more knowledge of Terraform, or maybe they're an admin, they can even create workspaces using this ServiceNow interface, configure variables, etc. So it's very flexible. And this integration is available through the ServiceNow marketplace. You're going to need to have a ServiceNow account and a Terraform Cloud for Business account, and you can install this after. So in terms of considerations, this is great for non-dev users because it broadens the audience of users for Terraform. Now it's no longer necessary for everyone to need to create Terraform code or deal with that directly. It can be abstracted by the ServiceNow interface. It allows creating a catalog of the valid deployment types. So for an organization, it allows them to predefine what are the resources that are available that can be deployed by this group of users. And with, as any enterprise workflows, it allows the centralization of this workflow and the governance. So you can define permissions, you can have the security, etc., in a more robust way. So this is a diagram that represents the different workflows available for Terraform Enterprise, where at the middle here we have infra end user. So these are the traditional Terraform developers, that they can continue developing their Terraform codes. And this code is going to live in version control systems that can be tied to the different workspaces. Or you can have a CI/CD tool that ties to the workspaces and uses API calls or remote states. You're going to have these infra end users. So these are the non-dev users that can leverage ServiceNow to define their deployment of resources. And then there's two types of users that I didn't spend much time, but are other workflows in Terraform. One is for the IT operators or architects. So this can be more advanced Terraform users that they can create modules. These modules are available for the traditional developers, or it can be catalog items for ServiceNow, but it allows independent life cycle of these modules best practice to be managed by Terraform Cloud. And finally, there's the security compliance team that can be responsible for creating the Sentinel checks. So Sentinel, like I mentioned, it's a feature of this Terraform Cloud Enterprise that allows these users to define rules of what's possible or not, what's within the compliance requirements of a company. So for example, you can determine that if the deployment has a S3 bucket, it can't be public. or if it's a certain type of resource that it needs to be tagged with the owner name. And maybe a question can pop up and somebody asks, what's the best workflow possible? Well, and the answer is, it depends. So one of the main objectives of this presentation is to show the versatility and flexibility of Terraform, both on the open source side and also on the enterprise side, to show that there's always options, and the best workflow is the one that makes sense for your use case and for your users. So if you want to expose the creation of infrastructure resources to a broader audience, maybe an audience that doesn't need to deal with Terraform directly, then ServiceNow is a great workflow. But if you're talking about developers, they need more agility, they know exactly what they need, and they look for the self-service nature, then you can have this VCS integration. And you're going to have the security and the compliance, so that's the security workflow for Sentinel, and the workflow for creating modules by the IT operators or architects. Where to go from here? So here is a link to the ServiceNow integration. It's not that complicated. It's about what I think now that's available on the marketplace, probably like 4 or 5 steps, where you go on Terraform Cloud and you create an API token and you create a team, and then you go to ServiceNow and you install that and you make a reference to the catalog items. So it's a little bit of back and forth, but once this initial work is done, the users of ServiceNow will have visibility of the different catalog items. And this is the blog post that did the announcement of this new integration, and it has a video showing this integration. So now I'll do a screen share just to show 1 minute of this video, so you can see what this workflow would look like. So this is the ServiceNow screen, and these are the different options that you're going to have. So this is an older version of the integration, so the newer version has more options, but the more important one here is provision resources. So what this means is just create the resources, and the other ones give you greater flexibility on that. And once you select, you're going to have the different VCS repositories. So these are your catalog items that were configured in advance. So it could be, for example, deploy Kafka or basic Lambda function or something like that that makes sense for your company. So you can have these catalog items. You can add a description of the request, and then you order now. So ServiceNow is a ticketing system, so it's like you would create a support ticket or something like that. But what ServiceNow is doing behind the scenes, it's reaching out to Terraform and doing the necessary logic. So creating a workspace, starting a run. And here on ServiceNow, you can see the output of Terraform. So you can follow if there's any errors or anything like that. It keeps you updated on what's happening. And once you have created something using ServiceNow, on the Terraform side, it's going to create individual workspaces, naming them based on the tickets that have visibility from Terraform Cloud. Can see what are the workspaces that were created using ServiceNow, and can see the status of those. And here she's just validating that everything was done. And on the ServiceNow side, you can see the catalog here she's going to add a variable. So to show that it has great flexibility. At the end of the day, this is just the API workflow, but it's abstracting behind ServiceNow. And you as an admin don't need to create those scripts by hand. We have these integrations ready following ServiceNow platform standards. And here she shows how the administration can be combined between ServiceNow and Terraform. So a run can be executed from ServiceNow, and an admin can go there and approve. So there's a lot of flexibility that can be done. And that's pretty much it for this presentation. I see there are 2 questions.
Yes, if anyone has additional questions, feel free to enter them into the Q&A box. I can go ahead and ask you the one that we have now. How does ServiceNow have the visibility of the existing resource? Will Snow CMDB be updated with the CIs once Terraform provisions a resource?
Right. Thank you for that question. So this is an independent workflow. ServiceNow is only going to have visibility of the resources that were created using ServiceNow. So if you already have Terraform Cloud and you have different deployments, you have different workspaces, those are not visible to ServiceNow. ServiceNow, once you install this integration, is going to be a blank slate, so there's nothing. And like in the demo, once you create these tickets, it's going to create different workspaces in Terraform, naming the workspaces based on the ticket name. And those resources will be visible from ServiceNow, but anything else is not going to be visible yet.
Okay, great. And then I don't see any other questions. I'll give it just a minute if anyone else has anything to ask. Otherwise, thank you so much for your expertise, Daniel. And as I mentioned in the beginning, the session was recorded and we will make that recording available on our website after processing. I'll also send an email out to everyone with the recording link. Oh yeah, another question came in. How about drift management?
Yes. So the idea is that these resources are only going to be created from ServiceNow sides, and you create from ServiceNow, Terraform executes, so these resources are created, and you have the visibility on ServiceNow. If somebody goes behind the scenes and changes directly these resources, neither Terraform or ServiceNow is going to know. However, like I showed on ServiceNow, you can provision new resources, or there are different options to rerun the provisioning, or to specify a variable, etc. So in that case, you could execute again, and that would be the moment where you would detect that there has been a change. But it's not like it's running behind the scenes to ensure that it remains consistent. Neither ServiceNow nor Terraform works that way. In the end of the day, if that's a concern for you, you can have some sort of cron job or something behind the scenes that from time to time is going to run Terraform again to ensure that it doesn't deviate. But ideally, once you implement these workflows, you prevent people from manually changing this infrastructure. Because the idea is infrastructure as code, so every change should be done either through ServiceNow or through changes to Terraform itself.
Great, and I will give it a minute in case anyone has any follow-up questions. Looks like we're good. So that should wrap things up for us. Hope everyone enjoyed today's webinar. and have a great rest of your day.